Hi, my name is Zack Simpson, and I'm here to ask you guys a question. What will we do when our natural resources are depleted? Well, right now we have two options, wind energy and solar energy. First, let's talk about wind energy. It's renewable, there are no emissions, but it's a great threat to the wildlife because of the amount of digging we have to do and the amount of space that we have to create to put these up. And it's not dependable. It's not always windy. Second, let's talk about solar energy. It's renewable, there's no emissions, but it takes a lot of land for commercial use, and like wind, it's not always sunny. But there's a new technology called triboelectric nanogenerators. It's not dependent on the climate, and you can collect energy from virtually anything. Walking, running, driving, riding your bike, anything you can think of. And its parts can be made from recycled materials, which makes it cheap. It's a possible answer to America's depletion crisis, and the bad thing is that it's not a fully developed technology. Now, what is it? It's a technology made by a man by the name of Zhongling Wang at the Georgia Institute of Technology. What it is you take two neutral materials and you put them together. This contact creates a charge separation, and when you separate them, you collect this charge and make it into energy. Now, how does it work? Triboelectrification is not a new thing. We've been doing it forever. When touching fur to glass, it creates a static charge. But this new study uses nanosurfaces. What these nanosurfaces do is it increases the surface area, and it uses the gap separation technique so that we can obtain more energy. More energy means it's a more valuable source of power. Now, can it generate large amounts of power? No, not at the moment. It's still very, very young technology. And right now it can power multiple devices such as laptops, your phone, your tablets, and self-powered sensors. Right here I have a graph of January 2012 and January 2013. And this is how much the technology has grown. In the beginning, it started out being able to produce 3.67 microwatts per meter squared of energy. Now, it's at 313 watts per meter squared of energy. So you can see, we're about right here, and this is where we need to be. So we're pretty far off from where we want to be. Now, what are its applications? You can literally use this technology for anything. You can put it on wind, rotational mechanical energy. You can use it for flowing water, anything you can think of. It can use these triboelectric nanogenerators and apply it to them. We can collect this energy. So all this wasted energy throughout the day, from walking, driving your car, the dams all throughout the world, we could be collecting this energy. But what is our big goal? We want to collect the energy from waves. Theoretically, a single wave generates 31 terawatts of energy. This is 2 times the world energy consumption. Now, if we can just harvest some of this, or maybe even half of it, our resource depletion problems would be solved, and the world energy crisis would be no more. But we're a long way from that goal. From the beginning to now, the technology has increased by 100,000, but we're still miles away from where we need to be. Thank you for listening to my presentation, and goodbye.